Good morning, Castle Heights students, and happy Wednesday, and also happy first day of April. So today I want to kind of review / look over our exponents that we talked about a couple weeks ago. So I'm going to just jump right into it so that as soon as you understand where we're going, you can get started on the work that I need you to do in Canvas. So first, we're going to look at this 2 to the 6th power. So we want to break it down and say, what is this 2 called? What is this 6 called? So the 2, the bigger number, is your base. The 6, your smaller number, is your exponent, right? What we're talking about. So when we have exponents, really we're saying 2 to the 6th power is we're multiplying 2 by itself 6 times. So if you ever need to write it out so you can physically see it, you're really going to have 2 times 2 times 2 times 2 times 2 times 2. So you have 1, 2, 3, 4, 5, 6 2's there multiplying by themselves. So your answer, if you do 2 times 2 times 2 to the calculator, you should get 64. Obviously, the quicker way is for you to type in 2 and then raise it to the 6th power and just press enter, and you should still get the same answer of 64. This is just our expanded form way that we could also write it out. So talking about a little bit of vocabulary words, we have squared. So we have 4 squared. So what this squared really means is to the 2nd power. So when we see 4 squared, we're going to have 4 as our base and 2, or the squared, as our exponent. So we should have 4 to the 2nd power, or simply 4 squared. Over here, we have 5 cubed. So the key word here in this is cubed. So cubed really means to the 3rd power. So when we have 5 cubed, we have 5 as our base and 3 as our exponent. So now we have 5 to the 3rd power, or simply 5 cubed. So that's kind of just some little bit of refresher on some vocabulary and making sure that we know that the big number is called the base and the smaller number is called the exponent. So now if we jump down here to the bottom, I want to talk a little bit about multiplying these exponents together and dividing them, and then what happens if you get a negative exponent. So the first one here, we have 3 to the 2nd power and then 3 to the 4th power. So when you're multiplying exponents together and they have the same base, all you're going to do is add the exponents together. Okay, so let's look. We got the same base. We have 2 3's here, so your 3 is going to stay the same. And then you're going to add this 2 and this 4 together, so it should give you 6. So your answer is 3 to the 6th power. If you want to keep going and simplify it further, that's fine as well. I'm just going to stop right there for right now. Now this one looks a little bit different. Now we have a 3 to the 4th power inside the set of parentheses with a squared on the outside. So there's 2 different ways you can look at this. When we have a 2 on the outside, or any number on the outside, we're going to multiply it by the exponent on the inside. So I'm going to put a little times there. My base is going to stay the same, so I'm going to keep my 3. And then I'm going to do 2 times 4, which is 8. So my answer is 3 to the 8th power. Now, there's another way you can do this. Break it down a little bit if you'd like. So this squared says there's 2 of everything on the inside. So we can break it into expanded form and write 3 and 3, right? We have 2 3's, and we also have 2 exponents of 4. Now we can use our rule from over here, same base, add the exponent, right? Same base. 3 stays the same, add the exponent, which is 8. So you should still get the same answer in both situations, just done 2 different ways. Like I always say, I don't mind which way you do it, just make sure whichever way you do, you show your work. So that's what we have on multiplication. Now I'm going to jump down here, and I have division. So now I have 3 to the 6th power over 3 to the 2nd power. Same rules kind of apply like multiplication, but up here we added the exponents. When we do division and we have the same base, now we're going to subtract the exponents. So again, the bases are going to stay exactly the same, so it's 3. Now we're going to take 6 minus 2. You just do it straight down. 6 minus 2, so our exponent is going to be 4. Again, if you wanted to keep going, you could, but for right now, I'm going to just stop there. 2 more things I want to show you. Next part is, okay, this is still division, so we have 3 to the 2nd power over 3 to the 6th power. So it looks just like that one, just flipped around. So we've got the same bases, so we're going to subtract. So we know that our base is going to be 3, right? It's going to stay the same. And now we have 2 minus 6. So over here we said it was 4. 2 minus 6 is actually negative 4. Okay, well, exponent rules say that we're not allowed to have negatives. It's just not allowed. So now what we need to do is if we have a negative exponent, we're going to take the reciprocal or flip it. So we talked a little bit about any whole number really has a 1 underneath it, right? If I were to ask you how to write 4 as a fraction, you could say 4 over 1, right? Any whole number as a fraction has a 1 underneath it. Same thing applies down here. So this 3 over negative 4 really has this secret 1 underneath it. So all we're doing is taking the reciprocal or taking these two and flipping them. So the 1 is going to go on the top, and the 3 to the 4th power is going on the bottom, but when you flip it, it turns this 4 exponent positive. So now this is our answer because we have no more negative exponents in our answer. Okay. Last part, just a little bit of a refresher. Anything, and I mean anything, to the 0 power is always 1. So no matter what you have, it's always going to be 1 if it's set to the 0 power. So if you have 5 to the 0 power, it's going to be 1. If you have 10,000 to the 0 power, the answer is still just going to be 1. So anything set to the first or the 0 power is always going to be 1. Hope this helps you guys out, and I hope you have a great and happy and safe Wednesday. Bye.